AI in software testing. In the next 10 minutes, I'm going to take you from zero to a genuinely useful understanding of this. What the tools actually do, where they help, and just as important, where they quietly fall over. Let me introduce the two characters in this story. On the left, a tester. On the right, a language model. And the model says something that turns out to be the whole subject. Can draft 100 test cases in a minute. I just cannot tell you which ones matter. So by the end of this, you'll know 4 things. What a language model is actually doing when it writes a test. The 6 places AI plugs into the testing lifecycle. Why AI can find a bug, but cannot decide that it is a bug. And the guardrails you need before any of it ships. No prior AI knowledge needed. Let's start with testing itself. Most confusion about AI and testing is really confusion about testing. A developer builds the path they expect a user to take. A tester's job is different. It is not to prove the software works. It is to find the places where it doesn't. Hold on to that, because it explains why AI is helpful in some parts of this job and useless in others. Every test everywhere has the same 3 parts. Arrange, put the system into a known state. Act, do the one thing you're testing. Assert, compare what happened to what should have happened. Remember that third one. Assert is where AI struggles, and we'll come back to it. Zoom out, and testing is a life cycle with 6 stages. Requirements, test design, test data, execution, triage, reporting. Every team runs some version of this, whether or not they use those words. Now, where does the effort actually go? Designing test cases and fixing tests that broke because the interface moved, and working out whether last night's failure was a real bug or a flaky test. Actually executing tests is the cheap part. Machines have done that for 20 years. The expensive part is thinking and explaining. And the pile only grows. Every square here is one test. Every release adds more, and almost nobody ever removes any. A few fail each night. Some of them are real bugs, some are just flaky. Someone has to look at everyone. 2,000 tests. 40 failed last night. Which ones actually matter? This is the exact moment every QA team decides to try AI. And that instinct is right, as long as it comes with rules. So let's talk about what AI actually is. Because 4 words get used interchangeably, and they really shouldn't be. Artificial intelligence is the outermost idea, any system behaving in a way we'd call intelligent. Inside that sits machine learning, which learns patterns from examples instead of following rules a human wrote. Inside that, deep learning, machine learning using neural networks with many layers. And inside that, large language models, the thing you actually chat with. Next time somebody says AI, ask which layer they mean. Here's the difference that explains almost every surprise you'll have. In a traditional program, a human writes every rule. Same input, same output every time, and when it's wrong, you can find the line. A machine learning model infers its rules from examples. The same input can give a different answer. And when it's wrong, there is no line to find. So, what is a language model really doing? Your prompt gets split into tokens, roughly, pieces of words. The model produces a probability for every possible next token. One gets picked. Then it does the whole thing again. That's it. It is not looking anything up. It is predicting the next piece of text over and over. 3 consequences fall straight out of that. First, it is fluent, not correct. A wrong expected result reads exactly like a right one. Second, it is not deterministic. Ask twice, and you get 2 different test suites. Third, it only knows what's in the prompt. It has never seen your application, your specifications, or your data. You'll meet 3 kinds of AI in testing. Classifiers, which sort things into buckets. Is this failure flaky or real? Which team owns this bug? Language models, text in and text out, write these cases, explain this log. And agents, which are a model in a loop with tools. It runs the browser, reads the result, and decides what to do next. That loop is worth understanding properly, because agents are where most of the hype lives. Think, decide the next step. Act, click, type, query. Look, read what happened. Then repeat. That's the entire idea. What makes it safe or dangerous is 2 things: a budget, in steps and time and money, and a hard boundary on what its tools are allowed to touch. Right. Back to those 6 stages, now with the parts AI genuinely changes. Requirements, test design, test data, and triage all change meaningfully. Execution and reporting barely move. We already automated those. Notice that AI is helping you decide what to test and what a failure means. It is not doing the running. Deep Dive 1, Test Design. The most common use, and the one people get wrong most often. A lazy prompt gives you 20 shallow test cases you'll delete. This is the version that earns its place. Give it your acceptance criteria. Ask for the boundary and negative cases a senior tester would catch. And then the 2 lines that matter. For each case, give the steps, the expected result, and the exact line of the criteria that proves it. And if no line proves it, write unverified. That single instruction removes most hallucinated expectations. Set your expectations properly. Roughly half the output is worth keeping as is. A few will be duplicates in different words. And 1 or 2 will be confidently wrong, which is precisely why you demanded a citation. Treat it as a first draft from a fast, confident junior who has never used your product. Deep Dive 2, Self-Healing Locators. The clearest and most measurable win on the whole list. Here's a checkout page. Our test finds the Pay Now button by its ID, Pay-button. Then a developer renames that ID to Checkout-submit. Nothing is broken for the user, but every test that looked for the old ID has just gone red, and someone loses a morning. A self-healing runner handles this differently. It re-identifies the element by its visible text, its role, and its position on the page, and proposes a new locator. With one absolutely non-negotiable rule attached. 0 silent heals. If the framework fixed something, that has to appear in the report. A heal you never see is not a passing test. It's a bug hiding behind a green tick. Deep Dive 3, Visual Testing. The one place a machine genuinely sees more than you do. Every build gets screenshotted and compared against a baseline. The old tools compared pixels and cried wolf at every anti-aliasing difference. A modern one ignores harmless noise, timestamps, rendering differences, and flags the meaningful shifts. Which matters, because your functional tests can all pass while a button has quietly moved 30 pixels and landed inside a card. Deep Dive 4, Defect Triage. Where the hours quietly disappear on a busy team. Every bug report gets turned into an embedding, a list of numbers that captures its meaning rather than its exact words. Reports about the same underlying problem end up close together in that space, even when they are written completely differently. So when a new report arrives, you place it in the same space, and if it lands inside an existing cluster, it gets linked as a duplicate instead of being investigated all over again by a second engineer. Deep Dive 5: Risk-Based Selection. The single change that actually shortens your pipeline. Here's your whole regression suite again. Instead of running all of it on every pull request, you rank it using the code diff, the module map, and which tests historically caught bugs in those modules. Then you run the top slice on every pull request and the full suite overnight. And be honest about what this buys you. Selection buys speed. It does not buy coverage. Deep Dive 6: Test Data. Boring, unglamorous, and the one your DBA will thank you for. Give the model your schema definition, and it generates rows that actually satisfy your types, your constraints, and your foreign keys. Valid data that loads. But the real trick is asking explicitly for the awkward rows, an apostrophe in a surname, a quantity of 0, a leap day, a negative number, a Unicode name. And this is the one I'd argue matters most, because it changes something structural. No production personal data ever has to leave the building. Your test environment stops being a compliance risk. And because the generated rows respect your constraints, they actually load instead of failing halfway through. Now the honest half. What AI cannot do. Skip this part, and you will ship a very confident mistake. Listen to what the model says here, because it's the most important sentence in this video. Can tell you exactly what the screen shows. Cannot tell you what it should have shown. That's called the Oracle problem, and it is the permanent limit on automated testing. Correct behavior lives in somebody's intention. It is not written on the screen. 4 honest limits then. The Oracle problem we just described. Fluent wrongness. A hallucinated expected result is indistinguishable from a real one until it costs you. Non-determinism, which means review never ends, because the same prompt gives you a different suite tomorrow. And no accountability. A model cannot sign off a release. A person has to. None of these are temporary gaps waiting for a better model. They are structural. So here's the split. Oversold. Fully autonomous exploratory testing, AI verifying its own expected results, an agent with right access to production, and the idea that you can replace testers with a subscription. What actually holds up? AI drafts and an engineer approves. A second model as a critic, never as the author. Read-only access on a replica. And testers who direct the tools rather than compete with them. Which brings us to the guardrails. 5 rules, and I put all of them in place before the first AI feature reaches a release branch. 1. Every AI-written test is reviewed by a human before it's allowed to gate a build. 2. Every automatic fix is logged in the report, no silent changes. 3. Any AI that touches your database gets its own read-only role on a replica. 4. Statement timeouts and row caps, because a model will cheerfully write you a Cartesian join across your 2 largest tables. And 5. Treat every model output as untrusted input. Parameterize it. Never concatenate it into a query. The database half is about 8 lines. Create a role. Grant connect, grant usage, grant select, and nothing else. Set a 5-second statement timeout. Point it at the replica rather than the primary. 10 seconds of work today against a very long incident call later. If you want to actually start, here's a month. Week 1, take your 10 flakiest tests and ask AI to rank the likely causes with the evidence it used. Week 2, add the cite the specification line rule to your test generation prompt. Week 3, generate synthetic test data from your schema instead of copying production. Week 4, measure one number, pull request pipeline time before and after. Small, reversible, and each one gives you something you can show at the next retro. And this is where we end up. You draft and decide. That division of labor hasn't changed, and it isn't going to. Learn the tools, keep the judgment, that's the whole job now. That's AI in testing, honestly. If this was useful, subscribe to Quick Tech Update. The next lesson takes a real flaky test suite apart, step by step. Thanks for watching.